So we're looking at inverses again. This is lesson 7, day 2. We were exposed to inverse already, and the symbol is f to the minus 1x. We're going to have to be a little bit careful today because it's possible that the inverse is not a function. So it's possible that f to the minus 1 of x is actually not a function. And if that's the case, we actually have to relabel how we communicate what we've created. And that relabeling looks a little bit weird. It's relabeled to be this. X equals a function written in the equation or written in the variable of y. So this is if I fail the function test. If I fail the function test. So remember, we've been finding inverses by making x equal to y. We've been finding f to the minus 1x by simply switching x's and y's. We've been doing it algebraically. And you should also be looking at a pattern which is called reflecting in the line y equals x. I think we'll see the reflecting a little bit better in our next chapter, but it's worthwhile understanding what that reflection does. We'll try to highlight some of those graphs as you build them. Please note that the domain of the inverse is the range of the original function. So your domain becomes your new range, and your range becomes your new domain. That's going to be weird. And we just talked about how the inverse of a function may or may not be a function. We're actually going to go all the way to class example number 2 and focus on the B selection. So class example 2, focusing on the B selection. Kind of follow the series of steps that's indicated for finding inverses. We saw that in the lesson associated with 6, but now it's made more explicit. So step number 1, replace my f at x with y, rewrite the statement. Awesome. Step number 2, flip the x's and y's around. So now the y becomes an x, the x becomes a y. That's step number 2. Step number 3, resolve for y. So a little bit of algebra, resolve for y. X minus 4 cube rooted is going to be equal to y. And then I'm going to replace my y statement with f to the minus 1 of x. And we'll be testing for that during this lesson, x minus 4 cubed. So that's how I find the inverse algebraically. Note where that minus 1 is sitting. I've turned the page to page 53. We're going to graph using our graphing calculator, x squared minus 4. You may know what that looks like. That's a graph that has its vertex at minus 4 and opens up. Use your graphing calculator to create that graph. So I've got my vertex and my x-intercepts on here. I'm going to try and sketch that graph. So there's a parabola. Graphing calculator is helpful. Now I'm going to go through those same steps and try to find the inverse. You'll note how the inverse is communicated here. That's giving me some indication that the inverse is actually not a function. I'm going to go through those same steps. Going to take the equation and replace the f at x with y. So y equals x squared minus 4. And then flip the x and the y. x is equal to y squared minus 4. Then resolve for y. X plus 4 square rooted would be equal to y. But now I actually get to say that it's plus or minus because I don't know. So I found some points. When x is minus 4, I get a 0 on the x-axis, and it's going to cut the y-axis at 2 and negative 2. So when x is 0, the square root of 0 plus 4 is 2. I've got another graph that looks like this. Try to cut that really close. And you'll notice that my new graph fails the vertical line test. That just is not good. I need to state the domain and range of what I was working with. Originally, the green graph has a domain, so x values, x can be anything. X is an element of the reals. Y was greater than or equal to 4. Y was greater than or equal to negative 4. And when I graph the inverse, I really should be flipping the domain and the range. So the domain and the range get flipped. So my x should be greater than or equal to negative 4, and my y should be an element of the reals. The inverse is not a function. We said that already. If not, could I restrict the domain or the range so that it's possible that it is a function? It turns out that this is a bad graph because it's symmetrical across the x-axis. And if I identify y as being greater than 0, I'm not going to have any troubles. So x is still greater than or equal to negative 4, but I want to say that y is greater than or equal to 0, which will eliminate the bottom part of the graph, or in a sense eliminate the square root with the negative sign in front. I'm down at the bottom of the page, class example number 4, and I've got a typical diploma question where they set up some information and then say that he did it either correctly or incorrectly. So I'm supposed to explain why Don's equation is not complete and why the graph of the correct inverse is not a parabola. So I'm going to try to determine the inverse of the original function. So this is what I have to get an inverse for. So it currently says y equals the square root of x minus 3. My y's and x's are in good spots. I'm going to find the inverse by replacing x and y. So that looks like fun. Then I have to resolve for y. So then I get x squared is equal to y minus 3, or x squared plus 3 is equal to y. So far I kind of like what Don has suggested. Don has suggested that the equation of the inverse is in fact y equals x squared plus 3. He got a parabola, which we're also going to get. So when I graph y equals x squared plus 3, it's up here and it opens up. Don's original graph, y equals the square root of x minus 3, would have been at a different location. It would have started at the x-axis at 3 and then opened up and went on for infinity in that direction. So I'm pretty happy that both are functions. The green one is a function, the red one is a function, but what's the problem? The problem is what happens to the domain and range. The original green function had a domain that said x must be greater than or equal to 3 and y was greater than 0 or equal to 0. by the time I graph my inverse, I have to flip the x and the y. So the red graph is supposed to be my inverse function, and my domain should say that x is greater than or equal to 0, and y is greater than or equal to 3. Y is greater than or equal to 3. Well, do I have x greater than or equal to 0? I have way more than that. I actually have to eliminate this part of the graph. That is not a part of the inverse. The only part of the inverse is that which corresponds to the domain and range restrictions. That's what's going to define my inverse. So this is a very tricky question. I've got one question to do, and then I actually have a challenge for you to do. You can either do the challenge after you're done the homework, or try the challenge earlier. It's a doozy. I want to turn over to class example number 5. And we're wondering here what happens when you take the function and its inverse and apply it in that composite manner. So what happens when I go f of f to the minus 1 of x, or f to the minus 1 of f at x? Now I want to give you a hint. That hint is over here in the corner. What happens when I take the tan of 50 and then go tan to the minus 1 of tan 50? Try that out so you can anticipate what's happening here. In class example 2, we previously manipulated an equation, and I'm going to bring back what f, the inverse is. I actually want to work with the cubed equation we were talking about. So this is actually 2b. So it'll be a little different than what you might find in your answer key. So f at x is defined. We found f to the minus 1 of x as well. Just want to set up what that looks like. So I have to take function f and evaluate it with the cube root of x minus 4. And function f says what you have to do is you have to cube the contents of x. So x minus 4, the cube root, and I have to cube that, and I have to add 4 to that. So the cube root and the cubed undo each other. X minus 4 plus 4, I get back x. And I should expect the same results if I apply the composition in the reverse format. I'm going to do that work. Hopefully you can see what I had to do. My x for the inverse is defined by x cubed plus 4. I went into the inverse and plugged in for x cubed plus 4. Then I have to subtract 4. And then I have to simplify that. So x cubed plus 4 minus 4 is x cubed. And the cube root of x cubed is x. So this is a really neat conclusion that the composition of a function and its inverse will actually generate x. And you should have found that by going tan 50 and tan to the minus 1 of tan 50, that you'll generate that 50 back again. So we're to the assignment. I think I made one error in the assignment, so please check that with me. So the assignment actually should read 1 through 4, 5 BC, 7, 9, 10, do all the parts. There's some real mischief in there, and 11 through 13. On the next page of my video presentation, will be a challenge assignment. If you can do all of these, you have learnt the ins and outs of this unit and inverse. I'll write down the questions, and then that will be part and parcel of our work in terms of getting ready for a test this Friday. So this is a collection of expressions to find. Don't guarantee they're all functions, but we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 to find. And I've got one more that I think will drive you a little bit around the bend. So it will take a lot of math skill to find the answer for this one. Actually, I recorded the really crazy one. This one is really crazy. Really crazy. So hopefully most of Tuesday's class can be used for working on inverses, both lesson 6 and 7. We'll see you then.